Hey everyone.
Oh,
Hello.
Hello. Welcome to Space Club. Thanks again for joining. It's March 22nd, 2021. It's been exactly a month since we last got together to talk about what's been going on. And this month we're really just talking about perseverance again, because it's been its first month and it's always exciting when a mission is new. So we'll talk about what it's been up to. It's hit quite a few first major milestones. So that's what we're going to focus on today. So as usual, I'm Danny Bednar, a part-time assistant professor in the Department of Geography at Western University. I also work for the Canadian Space Agency during the day. So with me, I have Dr. Phil Stuke, assistant or professor emeritus in the Department of Geography at Western University, and space mapper. And below him there, if it's in the same order as it is for me, we have Dr. Tanya Harrison, Tanya of Mars, red hair fame. So we're going to be talking about Mars all, but I want to start off by asking Phil. Last week was the Lunar Conference. Usually you community this year, but how was the online experience, and any big news or anything that caught your attention?
I'm not really a big fan of online conferences and things like that, but I thought LPSC worked out quite well. I was quite happy with it. People could put up their posters quite early, so you got quite a lot of time to look through them. They could put up recorded talks quite early, so you had quite a bit of time to look at them before the conference. And that was a nice thing, I think, because you had a chance to check out a talk. And then later on, if you really wanted, you could go into the live version of it. Then there were some plenary talks that weren't done beforehand. They were the bigger ones, and especially for perseverance, they were really interesting. There was one particular plenary talk I was really looking forward to, and that was a Chinese speaker talking about their moon missions. But unfortunately, although there was a lot of sort of summary of things that I was already aware of, there wasn't really anything very new in it. We're still going to have to wait a little bit longer to find out how old the young lava flows at the Chang'e 5 landing site actually are. They're probably waiting for a paper to be accepted, but there was no news about that, unfortunately.
Yeah, so that's the issue sometimes with planetary sciences. There are these things called publication embargoes. So the science may already be done, but in the academic world, sometimes that's held off on being announced until it is formally published. So
yeah,
that's probably, as Phil says, probably the case there. Awesome. Well, I hope you get to digitally see a lot of your friends that you've been hanging out with there for the last many years. And in the future, I really hope to get back down there, all of us together, and actually get to hang.
Yes. And in that connection, I might say that there was at least one talk about policy issues relating to, I think people are getting very interested now in how we're going to deal with competing interests in the tiny little areas at the South Pole that people are going to want to go to.
Yeah.
There are lots of areas people might be interested in with ice in deep shadows, but the number of places where you want to go and land, where you've got lots of illumination, those are very small and very few. And so there's going to be competition for them. And that's going to be a very interesting thing to look at over the next decade or so.
Yeah. I hate to tell you guys as scientists, but yeah, eventually us boring policy people are going to invade all of your favorite topics, and ruin them with our human geography and our sociology and our law and all that. But bound to happen.
Well, maybe this is your chance to go back to LPSC, like get approved by CSA. You can pitch the space policy track. I'm not sure they've ever had one.
Yeah, I mean, a part of me kind of hopes they don't in some ways, because I would want to water that conference down. Like it's a really good, concise, although maybe with planetary scientists less so, but for me, it's really concise in that it's planetary science. Enough space conferences already are like everything space. And that can be a bit annoying sometimes. It's like, why am I in a GPS, or there's a bunch of GPS talks surrounding my like the talk I'm interested about, like lunar South Pole ice or something.
Right.
So yeah, I mean, I hope, I mean, LPSC is great and it has great reputation for being really science focused, but yeah, there's probably room there to sneak us policy people in once in a while. But I wouldn't want to ruin the whole thing. Speaking of science, I know, Tanya, you did some press this week, I believe, about a paper coming out of Mars, which is catching some attention. I know it's a little bit outside of your wheelhouse, but I know you also read it and provided a few comments to best you can, if you can run that down quickly.
Yes, this was a cool new paper that just came out last week, I guess it was, where the investigators led by Bethany Ellman's group out of Caltech, I'm blanking on who the first author was, but I believe it's one of her students, looked at the water that is retained on Mars and the hydrated minerals there. So all over Mars, we have minerals that are things like clays and sulfates, where H2O or OH, both of which we call water as geologists, are part of the actual mineral structure of those materials. And their study found that a lot of the water that used to be on Mars might actually still be there locked up in those minerals. And this is really interesting because we thought for the longest time that most of Mars's water had been lost to space. When the magnetic field died out, there was nothing left to protect it anymore. And so it probably just was lost in space as the atmosphere was blown away by the solar wind. You know, the water either sublimated or it froze into the ground in the ice that's there right now in what we call the cryosphere. But their estimates were up to like 85 or 90% of the water that was on Mars might actually still be there in those hydrated minerals. So that's really interesting because we have ways to liberate that water from minerals if we wanted to go there and utilize it for humans in the future. It's not quite as simple as just melting ice and turning it into liquid water, but there's certainly a way to do it.
Yeah.
Awesome. All right, well, let's jump in. Before we go to Mars, I have to interrupt with a little bit of history. I was scraping the barrel this time for March 22nd. Not a lot going on, a lot of astronomy, and a lot of human space flight. As you know, not my favorite topics. But so I went with astronomy because this guy's life was very interesting. Let me pull up my notes here. So this is Ulugh Beg. He was a 15th century Uzbeki astronomer. He, you know, in terms of his fame, his contribution to astronomy, he had a 40-meter diameter sextant built to track the stars. So you can imagine he came from some money. He was actually from a ruling class family. And impressively, him and his colleagues at this time calculated the sidereal year, which we can clarify, to about 62 seconds of what it actually is. So very high level calculation of the movement of the Earth in relation to the stars. So really, really impressive. He has craters, actually a crater family named after him on the western edge of Oceanus Procellarum. So if you're looking at the moon, to the left, there's a big dark area, and just slightly to the left of that is these craters. Yeah, more interestingly, so overall, a terrible guy. He probably had an entire city slaughtered in 1448. And then in his, I guess he was an astronomer in his off time, because he got into mostly kind of family quarrels about ruling territory. And this is why he was, I guess, slaughtering cities. Eventually, he was killed by an assassin who was hired by his own son. So fascinating life, did some astronomy, did some tyranny.
Some murdering.
Eventually, yeah, killed by his son. So that's what I could drudge up for March 22nd. He was, oh, I should mention, he was born this day, March 22nd, 1394. So that's space exploration in history.
We've actually got a good question from the audience, rewinding slightly.
Sure, yeah, no, as long as it's not about Ulugh Beg, because I don't know much more about him.
No, don't worry. So this was a question about why doesn't Earth's primordial water, why isn't that all locked up in minerals here? And that's a really good question. So on Earth, we have plate tectonics that helps us recycle a lot of the water. when you have things like subduction zones. And on Mars, there was no plate tectonics. So there was nothing there to recycle that water to get it out of the minerals once it had been locked up in there. And so it's just theoretically, at least according to the study, been sitting there for the last 3.5 to 4 billion years.
Right. That's why you tune in, to learn from Tanya.
And mostly Phil.
Yeah. Speaking of which, let's turn to Phil. So there is the secret code, and this is where we last left you, essentially, with Percy descending down, landing on the ground. It was February 22nd. It was 4 days after the landing. Not really much happening with the rover itself, other than the fact that it's on Mars. It's been a whole month. Phil has the rundown on everything that's happened since. So take it away, Phil, and just let me know when to advance.
Okay. Well, yes. Okay. So let's go straight to the next slide then. All right. Yeah. So today is the 31st Martian day on the surface, Sol 31. So we might very well ask what's up with Perseverance. And actually today it just drove a little distance. So we'll talk about what it's doing right now. But it is moving around on the surface now. And let's go to the next slide and just have a look. First, we should talk about where it landed. The whole purpose of going to this area was that you would be pretty close to a big delta. A big sedimentary deposit built out into a lake in the distant past. And that's it up in the upper left of this map. And you can see this map is divided up into squares with names in them. And Perseverance landed in a square with the name Canyon de Chelly, which is French, I guess, but it's, although it may be a French name, it's actually placed in Arizona.
It's Chelly's Canyon. I'm going to say I am a little bilingual, Phil.
Lucky guess there, Danny. Yeah, that's right. But rather than being in France, it's actually in Arizona, and all the other places that you can see. These are names of national parks, state parks, provincial parks, these kinds of things, nature reserves, different kinds of protected areas, and they're taken from all around the world. So, for instance, if you look a bit to the left, there's one called Katmai on the left edge there, which is in Alaska, and Channel Islands National Park, or I think it's a national park anyway. The Channel Islands in the upper right is I'm used to thinking of the Channel Islands as little outliers of the British Isles, but these are off the coast of California. And then just up above that, Ile Royale is in Lake Superior. So the names from all over the place. They're not all in North
We've
America.
got Shenandoah, which is a river that runs through West Virginia. That's the only one I know, but it runs through the hometown of one Zach Morris, Western.
That's right. Yeah,
Western's foremost moon map colorer.
That's right.
In it.
Yeah, that's right. Well, So even so, not all of these names are from North America. They're actually scattered all around the world. We just happen to be in an area with quite a few American names in it. But anyway, these squares were used for mapping before the mission. All the researchers individually got a different square to map, and place names are going to be taken from those areas. And in the case of Canyon de Chelly, which is I said it was in Arizona, it's somewhere there now. It's possible that it's in New Mexico, but I think it's Arizona. Anyway, it's in that area. And many of the place names are going to be taken from the Navajo language from that area. So some of the rock names that you'll see mentioned on maps a bit later on are Navajo words.
So this is something... Oh, sorry.
No, go ahead, Tanya.
Yeah.
This is something I've wondered, I think, especially on Perseverance. I never really thought too much about it before in missions when we were naming things, but looking at these maps this time around, the thing that stood out to me was, on Earth, a lot of stuff has been named kind of in reference to where it is or the things around it or what it looks like. And then we're just taking these place names that have nothing to do with anything on Mars and just slapping them on things. So I'm wondering why we don't make more of an effort to actually give Mars its own names and describe the things that are there relative to what is actually there. Like, there's no reason to call this one particular square Prince Edward Island. It has nothing to do with anything that is actually there. But what if you describe things in terms of, like, I don't know, pick different languages on the earth, but describe things like the bigger of two hills, or like the small hills in the distance, you know, kind of the old school way of geology naming.
Well, some things do take names like that. For instance, at the Pathfinder landing site, there was a pair of hills called Twin Peaks on the horizon.
That's true.
So yeah, you know, so, some of them do take names like that. But well, I don't know. You'd have to ask the people who do the naming, I guess, because it's not me. I just record the names.
Someone has a question about where's Jotunheim. I don't know where it is on Earth, but it is part of the fictional Marvel universe, and it might be one of its own realms in the Thor movies. So
yeah, well, it might be, but it's probably also a place in Norway or somewhere like that. I'm not sure where. And you can see Spitsbergen. It gets its name right in the upper left there.
Okay, so agree to disagree. It's either in space or in Norway.
I don't remember if you were on the analog mission that year, Danny. Did you ever do any of the CSA analog missions at Western?
I did, and we had a Jotunheim rock.
I was going to say, one year the whole theme was like Viking mythology, and we had Jotunheim.
We also had Hans Rock, but we only ever called it Hans Gruber, and we made up that Gruber meant rock in another language.
Okay.
These are very serious science times.
Okay, let's move on before we get too bogged down. And the landing site was named after Octavia E. Butler, a science fiction writer who was born in Pasadena. And this is actually following on a little tradition from Curiosity, where the Curiosity landing site was named after Ray Bradbury, another science fiction writer. So perhaps we'll see more of that in the future. I don't know. Yes, so somebody put up a comment there about the names of valleys coming from the names of Mars in different languages. And we'll see another instance of that in a moment as well. So, okay, Perseverance. First thing you do, you land on Mars, clunk, you're on the surface. Now you've got to check everything out and make sure it's all working. And these are very, very complicated machines. Curiosity, Perseverance, incredibly complicated machines. It takes a long time to make sure that everything's working right. And for Curiosity, everything wasn't working right. One particular thing, a wind sensor, was damaged in the landing and has never worked, although it had two of them and the other one is working. So anyway, this process is still going on, although largely done, and everything seems to be in really good shape. So those are just little bits and pieces of the rover. Then, of course, you take a look around. Here's one of the earliest panoramas, big panoramic views looking all the way around the horizon. You can see the rover sitting there as a big lump. It's kind of distorted in this version of the panorama. But to the left of it and to the right of it, there are little patches on the surface that are brighter than the surroundings. And those are places where the rocket exhaust from the descent stage blew away dust on the surface and left these bright patches. So we won't be seeing that elsewhere. And this is just an indication of how you actually put together lots and lots of pictures to make a panorama like that. This is from the Mastcam panorama, not the first one. But it takes a while to build it up. So here's a good animation showing how these images were put together. First, they photograph all around the horizon, then they do another tier below that, gradually fill it in, and eventually you've covered the whole thing. And then when you get that, you can display it as a horizontal panorama showing the whole horizon, or a circular thing like this, which looks more like looking down on the surface from above. And I like to take the horizontal panoramas and project them out into a version somewhat similar to this, which will then look like a map of the area that you're sitting in. Okay, let's move on here. So of course, you're going to take a look around in a bit more detail. So here's zooming in on features. This hill is in that quadrangle or map area called Katmai, and the hill is called Kodiak. Katmai is in Alaska, Kodiak Island is in Alaska. So as they look around, they're already looking far enough to be in other map areas, other quadrangles. and assigning names appropriately for those places. So this hill is Kodiak, and it may be an erosional remnant of the delta. When we look at it, we can see where the rocky outcrops stick out. You can see layering in them, layered rocks, which might be parts of those delta deposits.
Yeah, so I wanted to ask about that because this was also released as like one of the fancy cleaned up public image, and they really just said with the caption, "This is expected or hypothesized to be part of the delta."
Yeah,
but there's not really any annotation showing like why do you think that, or like what is part of the delta.
Well, you don't get that from looking at this picture. You get it from the orbital data, and the orbital data shows the big delta, and then it shows a few isolated hills around it, which might be remnants of what used to be a larger delta that's been eroded back. So that's what they're thinking. I should say that the space up at the top of this image is not the sky with some funny looking dark clouds in it. That's actually part of the crater wall looming high up above this hill.
I was going to ask because it looks like it's right behind this rock, but I imagine that may not.
No, it's not. It's a long way back.
Yeah.
Maybe that hill is about maybe 2 kilometers from the rover, and the crater rim is probably maybe 15 kilometers away, something like that, 10 or 15, some distance behind it. Okay, let's move on there. And of course, you take a look around and you find some funny looking rocks, and some of them have been given names. This one is the first name that I found. It's been nicknamed the Harbour Seal. Jim Bell mentioned the name in a talk that he gave. So it's a little nickname, and people do give funny names to some of these things. But as I said, the majority of names in this area will be taken from the Navajo language. From the Canyon de Shelly area. Okay, let's move on again. Oh yeah, and right, Danny provided this. So
well, I didn't provide it, but
well, no.
Just before we talk about it driving,
right. So over on the right-hand side, just a bit below center, near the right-hand side, there's a little white dot, and that's the landing site. And from it, there's a little purple line that goes kind of clockwise, loops around, and actually comes up next to that hill Kodiak, very close to that hill Kodiak. And there's also a blue line that goes the other way around, and ultimately they come back to the same place. So these are two different paths that the rover might follow in order to get onto the yellow line, which is where they want to do the sampling. And they haven't decided which way they're going to go yet. What I've heard is the purple path is more interesting. But it might be more difficult, so they haven't decided yet which way they'll go.
Is this Kodiak?
No, the big hill just to the left of the purple line. That one.
Oh, okay.
That's Kodiak.
I see.
All right. Okay, so after spending 13 Martian days or sols checking everything out, on sol 14, they actually made a first little drive. It was only about 6 or 7 meters. You can see the two parallel tracks at the back of that image. They just start from nowhere because that's where the rover just plunked down on the ground. So when they start to drive, they drive away from that. There's nothing left to look at except the tracks. Yeah. And they are about, not quite, but nearly 3 meters apart, those lines. Maybe 2.7 meters. So getting up towards about 9 feet.
This is 3 meters, Phil?
Yes.
Okay. Wow.
Between the lines there. The rover is about 2.7 by 3.2 meters or something like that, the wheelbase. I forget the exact numbers, but that's approximately. So they drove from there towards the foreground. There's a little circle of tracks where they spun around a bit, and then they drove down a meter or two in another direction. You can see the bright spots which were made by the landing exhaust up in the upper left and right. But now they're driving away from them. They might be contaminated, so they're not going to spend too much time near them. So now they've driven away. Okay, and let's move on there. And I think you've got an animation here of the drive.
Yeah, so this was also posted again in the public images.
Yeah. Can we does it want to animate? Oh yeah, there we go.
Yeah, so
drive a little bit.
Rover. It sits there for a
And
while and then moves. And then sits there for a while.
Perseverance is saying, "Is there somebody behind me?"
So,
but
the next day, this was March 5th after the first drive. It was a
been
post-drive recreation.
Yeah.
The engineering team with their 3D models there, which is actually something we kind of, not this cool, but somewhat close, had like static versions of this on the animation. But yeah, these 3D models are used to kind of get a sense of where everything is, and they can overlay pictures into the model based on all the cameras they have, just to give them a third-person view of what things might look like.
Okay, let's move on there. So this is just a little map showing that first drive. The bright spots are labeled descent stage rocket scour, where the dust has been scoured away by the blast of hot gas coming out of the rockets. And down at the bottom is the Harbour Seal rock, but close to the landing is a rock called Mars. And that's the Navajo word for the planet Mars. So that was the first science target. They used the SuperCam instrument. I thought, yeah, we have a picture of that Mars in a minute. We'll come to it later. But it was the first science observation. We'll talk about it when we see the picture. And then they drove away from there. If we're making maps like that, how do we know where the rover actually is? What I like to do is to take the panorama, which I've done here, just a very crude, quick panorama put together from the pictures, and then project it out into a form like this. I can see the horizon all around, so I can sort of figure out the directions to things, but also I can see where the rocks are scattered around it, and then figure out from orbital images where the rover is relative to those rocks. Okay, here's Mars. The first scientific observation using the SuperCam, and the SuperCam has a laser. It's like another instrument on Curiosity called ChemCam. It fires a laser at the target, and not just once, but multiple times. And the laser energy vaporizes, well, in fact, ionizes a little bit at the target, and you get a flash of light, and the spectrum of that light tells you something about the composition. So it's a good way to get composition from something. You don't have to touch it. You can be 3, 4, 5 meters away. I think it works up to about 7 meters away. So you don't have to be right there touching it. But you can get good compositional data. So that was the rock, and here's the image taken by the SuperCam instrument itself, which is centered right on the spot that they get the data from. And often when we see images like this from Curiosity, I haven't seen it yet with the SuperCam images, but with Curiosity, you often see a little row of dots where they've fired the laser multiple times at different spots as they scan across the surface, or even a kind of a grid-like pattern covering an area.
Yeah, and Phil, just some stats that just for this particular image, the target Mars was 10.4 feet or 3 meters away from the rover. Yeah, there's some early assumptions about igneous material within the rock, whether the rock itself is igneous or just some components, grains of igneous material, is just what they sent along with the press release for this image.
Yeah, and I think that little circular image, it's only about 2 or 3 centimeters across, so it's quite a close-up view of that. Yeah, very nice. Okay. All right, so then I've got a map here that just shows more of the drives. They drove away from the landing site north, and then looped around to the east, and came out into a slightly rocky area, where they have, that map shows that they've discarded something called the belly pan. We'll see a picture of it in a minute, and I'll talk about it then. But what they're doing, one of the early things they want to do with the rover is to test out a fantastic little machine, which is like a little helicopter or a drone, you could think of it like, which will be set out on the surface, and then we'll do some flights. The first time anything is flown like that on another world. It's an experimental thing, but they want to make sure that they can fly it and control it and land safely. and it will take pictures. It's really an experiment, but the idea is that in the future you might be able to use something like this, let's say, to fly ahead of the rover and help to map out, let's say, the way to get around an obstacle up ahead, something like that. Or you could use it to fly up to the top of a cliff that the rover doesn't have a hope of getting to, and making measurements of rock layers at the top of the cliff. It might be out of range of supercam or something like that. So that's the plan. This is just an engineering test. We don't really know how much it will be actually used. Anyway, they want a nice smooth area to do that. And I think the smooth area will be in the upper left of this image. And that's where they'll fly the helicopter. But first they have a couple of things they've got to drop off the rover. The first is this thing called a belly pan. So they drove out of the area they want to test the helicopter in, over into a more rocky area. And they parked, and then they dropped this belly pan. And the belly pan is like a plate that protected the sampling system on the rover. The whole purpose of this rover is to collect samples and cache them on the surface, or leave them on the surface for pickup by a future mission, which will bring them back to Earth. So the sampling part of the rover is incredibly complicated, and it has to be kept extremely clean. So you can't have all the debris from the landing being thrown up into it. So it's protected by this belly pan. Now it's been dropped. Oh yeah, Phil says I'll be mapping. I will be mapping. That's right. Yeah, so the belly pan's discarded there.
For the next slide, you mentioned something interesting, Phil. You mentioned obviously Ingenuity likely to be the first object to fly on another planet, but I want to poll just amongst the three of us. Does the Apollo ascent stage count as flying on another world, or is it just a launch? We could get into an argument about whether launching is flying.
Well, I'm talking about what we might term aerodynamic flight here.
Okay. Fair. I guess that's
yeah.
I'm sure Tanya's gonna side with Ingenuity.
I mean, I side with Phil here.
Well, I wasn't disagreeing. I was just forcing people going, well, actually.
The thing is, Danny, if you want to quibble, Danny, I'm going to wag my finger at you. If you want to quibble, you should be quibbling about the Soviet Union's Vega balloons that flew in the atmosphere of Vega. But that wasn't powered flight. It was balloon flight.
That's true. I do always side with the Soviets. Something I should say on the internet.
Daniel will be joining us next month.
Yes. That statement is there forever.
The 30-year defunct empire is who I'm allegiant to. What about bouncing? Is bouncing flight? Because then Philae could arguably be the first flying spacecraft.
Well, it wasn't aerodynamic, though, was it? That is, it wasn't governed by fluid dynamics in the atmosphere.
Okay.
Well, if you're talking bouncing, though, then you've got all the airbag landings on Mars, because they kind of flew until it bounced again and again. You're getting into all these technicalities, Danny.
It's true. Yeah, the MERS, Oppie, and Spirit were the first Martian bouncers, which they never...
No, Pathfinder was.
Everybody forgets about Pathfinder, Danny.
Yeah, but that was before I was interested in space. So
there you go. All right.
It goes up until the end of the Soviet Union, and then I skipped the 90s, and then 2003. All right, let's keep going here.
Okay. All right, there's the belly pan. So it's at the front of the rover and just underneath it. And that's where the sample caching system is. So you can imagine what's going to happen later on when they start collecting samples for return to Earth. The robotic arm will reach out in front of the rover and touch the surface, and it will drill down into the surface and collect a little plug of rock. And then it picks it up and pushes it up against the front of the rover, where it enters into the very complex sort of sample distribution equipment, which will collect it and put it in a tube and move it around and so on, and eventually it ends up underneath the rover. The whole thing is a complicated procedure, but it's going to end up there. And so it's where that tube ends up that had to be protected by this belly pan, and now it's been dropped. And there it is. So that after that, the rover backed up a little bit and then dropped another thing. So over there on the right-hand image, you can see this funny-looking pan-shaped object, which is called the debris shield. And that was covering the helicopter. So actually, up above it, there's some funny little odds and ends there, which are actually part of the helicopter, which is all kind of folded up. So it was installed under the rover, folded up. This belly pan is put on to protect it, again, from all the debris during landing, because those the descent stage thrusters throw up an awful lot of stuff. It's flying around at high speed. It's got to be, everything's got to be protected from that. So so now that's been dropped. And that was dropped yesterday, sol, as they like to say at JPL. It was dropped yesterday. And today the rover drove away from that and back towards the smooth area where they will deploy the helicopter itself. This whole business with the helicopter and the belly pan, or not the belly pan, sorry, the debris shield, it has to be dropped off very early in the mission because you can see from the depth of it that it actually stuck down quite a long way below the rover. And that significantly reduces the ground clearance of the rover underside. So if you're driving over a rocky surface, you don't want a rock to come scraping into these things underneath the rover. So as early as possible in the mission, they had to drop that debris shield, then deploy the helicopter. Then after that, they can drive, pretty much anywhere they like.
And one of the other objectives is to test the autonomous driving system, which I have no reason to cheer for as an ideal component of this rover, other than it's being led by people who come from Western. But anything on the underbelly is of concern for the automated driving system. I know I was seeing a couple of discussions on they don't want to fire it up until they know the clearance levels or what the computer is expecting. So you can't have anything on the underbelly.
Yeah, right. Yeah, okay. So so that's pretty much where they are today. Like I say, today they just drove away from there. And although I have actually got a map of the new location, I haven't got a chance to put it in with these slides. So they're beginning to move. They've got at least one more drive before they get to the place where the helicopter will be deployed. It's got the name Ingenuity and Perseverance, like Ingenuity and like Curiosity and like Spirit and Opportunity. We're given names by the public, and I think in every case these were actually public school children who were either individually or as a class were able to suggest a name. So all around the United States, these names were compiled and sent in, and they had a great big long list of them, and they chose these names. So yeah, Ingenuity. Did I spell Ingenuity right there? I might have misspelled it. I can't remember now.
I think it looks right.
Okay, oh, good. All of a sudden, it was looking to me. Okay.
I'm not sure about all the kids that named the rovers, but I know one of the girls that named, I believe it was Curiosity, is in science now. So it's really cool that she followed her path.
Yeah, that's great. Yeah.
I didn't name anything when I was a kid, but
oh,
I did fine.
All right.
I was surprised, Phil, because you actually posted in the Spaceflight forums, but the arm touched the ground. I don't know. I mean, to me, that's kind of a milestone. But they did test out the arm. They kind of flexed it, and it did actually make contact with the ground just for engineering purposes. I don't think.
Yeah, that was on Sol 28. Well, the arm has several instruments on it, right? So I'm not sure what was used when it touched the ground. I haven't heard that yet, but the arm has several instruments on it. On Curiosity, for instance, you have an APXS instrument, which is controlled by a team with including Ralph Gallert from Guelph, who's responsible for developing it. But there's no APXS on this this rover. But that's on the arm. So if you want to use APXS on Curiosity, the arm reaches out and touches the surface. But there's a microscopic imager on the arm, so they might have been testing that. I haven't seen the pictures. I'm not sure what they were doing, but they were testing it out, basically, testing out the instruments. And the sample drill is also on that, but they wouldn't have been testing that at this stage.
And Anvil Wonk points out the nicknames for the two, Percy and Ginny, which pretty British sounding names, actually.
Yeah, that's right.
I thought you'd like that more, Phil, but okay.
Okay. Yeah, so what's going to happen over the next little while? I think they have one more drive to do, might come tomorrow or very soon, out into the area where they'll deploy the helicopter. And then it has to unfold, and that's a complicated procedure in itself. It might take more than a day to do that, and it'll be dropped onto the surface. And then the rover will drive away to a safe distance, and it will be, sort of imaging what happens, of course, filming what happens, and the rover, the helicopter will be tested. The first test apparently is to spin up the rotors, but not fast enough to lift it up. They'll make sure everything's working, and then when they're satisfied, it will spin up faster and lift off and make a small flight, and then touch down, and they'll make sure they can land safely. So it's a lot of it is about making sure that they can control everything. They'll have to make sure that it's not too windy a day, because that could be.
How windy does it really get? It's Mars.
Well, it gets windy enough. It gets windy enough that I can tell you that actually they've already seen a dust devil moving past the rover.
Oh yeah, I saw that.
Yeah, so it can be pretty windy, and they'd have to make sure that they were in a
strong enough to move dust.
Yeah,
notoriously hard to move. Yeah, so I was just kind of looking at what else is, I guess, first business is the helicopter, like you say, Ginny, and then it's kind of picking that path. I imagine that when we saw the purple and the blue paths.
Yeah, so we'll go one way or the other around to the place where they get onto that yellow track where they want to start doing the sampling. Well, actually, they'll probably start sampling before that, but that's the main part of the traverse. Right now, they're in an interesting area, which is kind of on the edge of two different kinds of material. I don't know whether they'll actually sample both of those, but they might sample at least one of them. And one of the major sampling goals of the mission is actually the floor material of the crater. When they were planning the mission, everybody thought that the floor material of the crater is a kind of lava flow, a basalt lava flow, mafic minerals. And they're interested in getting a date from that because if you can count the number of craters that formed on that lava flow and get a radiometric date, a measurement of the age of the rock in the laboratory, then you can basically compare your crater count estimated age with your actual measurement of age in the lab. For Mars, we've got lots of places around the planet where people have estimated the age of the surface by counting craters. But even though we think we can do it reasonably well, it's not been calibrated by an actual measurement of the age of a rock. And this would be a good place to do that. It's not something you can really do with, let's say, something like the Delta, because the Delta has been so eroded that any craters that have formed on it may have been, older ones will have been eroded away. But out on the plains, if they're lava flows, most of the craters should have been preserved. So you could get a reasonable estimate of age by counting craters and then check it with a date from the lab if we can get those rocks back. So that's one thing I particularly want to do.
Before we get to Phil's question, I'm going to show off my geology. This is the Delta, and this is the plains. Whoops. Oh,
yeah, that's very good.
Yeah, there we go.
I had no idea you were so good at this stuff.
Well, Tanya, I think you might know the answer to Phil's question as well as Phil. Are you lost? She has no sound. She's broken. Phil, answer Phil's question.
I haven't seen what Phil's question is.
Oh, okay. Well, I know it's.
How far can Ingenuity scout? How does it communicate its images? So it uses this a sort of Wi-Fi link with the rover itself. It can't communicate direct to Earth. It can only communicate through the rover. So it can't go too far away. I don't know what the actual range from the rover would be, but it's not like they can leave it there. The rover can drive, 10 kilometers collecting samples, and the helicopter can continue working where it was. It can't do that. If it's going to stay working, it's going to have to follow Curiosity all the time, and I don't know how long they would expect to do that.
My mouse came back, so I could unmute. Sorry, it
your mouse broke.
It just froze, so I couldn't actually get it to go to unmute my microphone. From what I've heard, the maximum flight distance is going to be 100 meters. So I don't know if theoretically it could communicate farther than that, but they don't plan on sending it more than 100 meters from the rover. Line of sight.
Oh, they should just go 100 meters straight up and just see what happens.
Yes.
Yeah, there's not enough juice in it for too many flights. Is there like one?
Well, it has a little solar panel. It can recharge its battery, but it hasn't got a lot of power. But it does have a nice camera. It's going to take some pictures.
Yeah, and I think we talked about last time the images either of the rover and from the rover of Ginny or from Ginny of the rover, and hopefully get those.
Yeah.
Yeah. So Anvil Wonk there has a question. So the helicopter gets left behind after the flights.
Yeah, they're not going to try to pick it back up and piggyback it on the rover or anything.
Right. So Anvil Wonk there is asking if the rover will be left behind, and I think it will be. I don't know how long they'll stay with it, but it's definitely not the main purpose of the mission, which is sampling. They want to get out sampling. Ultimately, after they're satisfied with all the tests and they can plan for future missions with this technology, it will just be left.
Yeah, and because they're going to a safe space, which is going to be about 100 meters away. I assume the safe space is kind of the general direction they're moving anyways. I don't even think.
Yeah, well, probably, but yeah.
They're just ditching it. Okay, so before we wrap up, I wanted to have a little bit of fun. Today is the 90th birthday of one Willie Billy Shatner. And I don't like to advance the narrative that all space people like Star Trek. I like Star Trek, and most other space people I know like Star Trek. Phil, actually, you're not a big Trek guy, are you?
Not particularly, no.
So
I literally have 5 pieces of Star Trek jewelry on at the moment. And I didn't know that you were planning this for the live stream tonight. This was purely coincidental.
Well, I assume in general, at any moment, you're likely to have a bunch of Star Trek stuff on you.
That's true. It's all the stuff I wear every day. So.
So this is a trivia game in which no skill is needed. You're essentially guessing.
All right.
William Shatner has a celebrated career of many films. I'm going to read you a plot synopsis. Keep in mind that the level of films he's done. You're going to tell me Shatner or no Shatner. So I'll go first with Tanya.
Okay.
So Rhubarb, 1951. Rich eccentric T.J. Banner adopts a feral cat who becomes an affectionate pet. Then T.J. dies, leaving to Rhubarb most of his money and a pro baseball team, the Brooklyn Loons. When the team protests, publicist Eric Yeager convinces them Rhubarb is good luck, but Eric's fiancée, Polly, seems to be allergic to cats, and the team's success may mean new hazards for Rhubarb. No Shatner.
What a tragedy.
I just thought this plot was phenomenal.
I'm guessing just because of the year, no Shatner.
Yeah, this is a little early for even some of his earliest parts. This is actually an early background role for one Leonard Nimoy, who's
interesting.
Yeah. Okay, Phil. Shatner, no Shatner. The Hands of Orlac. A pianist who loses his hands in a plane crash receives the transplanted hands of an executed criminal, but his new hands have the murderous tendencies of their previous owner.
Okay, well, I think I'm going to go with Shatner on this one.
This is a no Shatner again.
Oh,
Yeah, this is a Christopher Lee pick.
Oh.
Okay.
Not surprising given the horror theme. Audrey Hepburn's hubby Mel Ferrer also in this one. All right, Tanya. The Explosive Generation, 1961. A high school teacher gets in trouble when he tries to teach a class in sex education.
I can see
It's
where
got
that could go
sex
wrong.
in it, so Shatner's here.
You are correct again. Shatner plays Mr. Gifford, a senior life skills teacher. I think we all want to go watch a movie about Shatner teaching that. Okay, Phil.
Oh.
Oblong Box, 1969. Aristocrat. Julian Markham keeps his disfigured brother, Sir Edward, locked in a tower of his house. Sir Edward occasionally escapes and causes havoc around the town. Shatner or no Shatner?
Okay, well, let me see. Well, I'm trying to imagine William Shatner with an accent rather like Prince Charles. Trying to make that leap of imagination there, and I'm not sure if he could pull it off. So I think I'll say no, Shatner.
You are correct. This is actually another Christopher Lee plot summary. I just found that when I was looking through his IMDb page, it had a lot of the more interesting summaries. So 2-1 for Tanya. Tanya, your last one. Big Bad Mama. Mama and daughters get forced by circumstances into bootlegging and bank robbing and travel across the country trailed by the law. Shatner or no Shatner?
I'm going to say Shatner.
Yes. Wow.
Yes.
3 for 3 from Tanya.
I've never
Shatner
seen any of these movies.
No, I imagine none of you had. I certainly haven't. He plays what Wikipedia calls a refined yet dishonest gambler, William J. Baxter. He is the love interest of the titular Big Bad Mama. All right, last for you, Phil, to a 2 out of 3. The Devil's Reign. A Satanist cult leader is burnt alive by the local church. He vows to come back to hunt down and enslave every descendant of his congregation by the power of Book of Blood contracts, in which their souls are sold to the devil. Or something. Shatner or no Shatner?
Well, I can definitely relate to this story because every time I'm burned alive, I always come back and haunt people. So, but I don't know. Let's say Shatner.
Correct. You
Yes.
get a 2 for 3. Shatner plays Mark Preston, the son in the family terrorized by the satanic priest, who was played by one Ernst Borgnine.
Oh.
I did 4 each.
Ooh. Okay.
Yeah, well, Tanya, bonus round.
Ooh.
Rural Arizona, somewhere you're familiar with, countless killer tarantulas are migrating through a farm town, killing every living thing in their path. The town's veterinarian will do everything in his power to survive the onslaught. Shatner, no Shatner?
I'm going to go with no Shatner.
Ooh, Shatner plays Rick, an investigative veterinarian hell-bent on killer spiders.
I have a chance to even this score now. You know, this story is rather like something happening in the news right now in Australia, where apparently floods are forcing spiders into people's houses.
Oh God!
Oh God! I am never taking a job with the Australian Space Agency.
No.
I'm just so afraid of Australia, but the people are so lovely. Just terrified of their insects.
Right. Yes.
Senior moment 2021. Stripped of his driver's license, a retired NASA pilot must not only battle with the DMV, he must find new ways to navigate love and life without his beloved vintage Porsche.
This has got Shatner written all over it. Come on.
I guess. Yeah? Your answer?
Yeah, he's in it.
Yeah, he's the lead. This is coming out.
Yes. It's a tie, Tanya. It's a tie.
Yay!
You're equally great.
At guessing.
Yes, yes. But I mean,
Educated guessing.
yeah, you guys did well. Three out of four each.
Yeah.
Very good in a career that has spanned 8 decades, 9 possibly.
Who, mine? Oh, Shatner's, right? Yeah.
Yeah. Not yet, Phil. Not yet, Phil. Well, Phil comes back every month. Cass enjoyed this show, I hope. Phil McCausland, I hope you come back every month. Great meteorite expert and curator. I can say I know a meteorite curator, which is pretty cool. Just carries a briefcase full of super secret rocks.
A pretty sweet gig.
Yeah.
We're also going to give Cass nightmares, apparently, thanks to giant tarantulas and Australian spiders.
Yeah, that's tough, but she can handle it. Yeah, well, I hope everyone enjoyed it. This week, Tanya, do you have any things coming up, appearances, whatnot?
Yeah, I guess this Thursday at 7 p.m. is the next Women in Space seminar. Our speaker this week is another Canadian, Renee, Holzik. I'm really sorry if I butchered your last name. And she's going to be talking about new ways of dealing with imposter syndrome. So it's an interactive workshop that should be really good. So look on Twitter at the hashtag Women in SpaceCon, and you can register for free on Eventbrite through the tweets there.
A good way to not get imposter syndrome is don't start a YouTube chat about planetary science with planetary scientists when you have no background in it. So just a word to the wise.
I will say that I really understand imposter syndrome, because that's exactly what I felt like when I first walked into my office at Western. Fresh out of grad school, suddenly I'm in an office in a university somewhere, and I just kept thinking they're going to find out I'm here and kick me out.
How old were you when you started as a professor?
Oh, let me see. 88, I was 36.
Okay.
Yeah, so I did other things before I went to grad school.
You can read all about them. Oh, we didn't plug the book once this episode. You can read
shoot. You can read about
life.
Phil's life in our book.
A little bit of it anyway.
Oddly enough, I also have a panel this week. I'll be talking to the Space Society of London, actually with Catherine Nish and Gordon Azinski on the panel as well, about aliens, which will be interesting. But I guess it's what it's the undergraduate space club at Western, and they have questions lined up for us about contacting intelligent life, which is I'll watch Contact again and beef up on my Carl Sagan.
Okay.
And Phil, you'll be rummaging through the LPSC abstracts, and
I've already done a lot of that. I'll be trying to keep up with mapping what insight and curiosity and perseverance are all up to on the surface of Mars, and Chang'e 4 on the Moon. So every time something happens, I have to make a map of it.
Well, maybe next month we'll have to. We
can look at some of those other things. Yeah.
Yeah, we can't leave Mars totally behind because Percy's so much.
Even Insight is busy right now, digging trenches in the soil and starting
that old thing. Yeah. Insight. We'll have to check in on some of the other missions next month. But Percy deserved.
And if you want to, sorry, go ahead.
No, I was going to say Percy deserved 2 months, but yeah, go ahead, Tanya.
I was going to say, if anybody wants to check out Phil's maps asynchronously from these talks, you can go to unmannedspaceflight.com. And there's tons of maps there by lots of people, processed images. It's a great place to nerd out about all this stuff.
Yeah.
Yes. So thank you to everyone who uploads images, and that if we ever use them, of course, we give you full credit, as should always be done. So thank you everyone for joining. Follow Tanya on Twitter at Tanya of Mars. You can follow me on Twitter for some reason if you wish, at Danny Bednar. And like we said, you can always keep up with Phil and other brilliant space people at unmannedspaceflight.com. So with all that, thank you very much, everyone, and we'll see you next month.
You bet. Okay.
Hi, everybody.
Bye, everyone.